Assalamualaikum. I have tried. This thing is not adjusting properly. So forgive me. Yeah? It's going to be like that. Just one moment. Let me switch off the air conditioner. It doesn't make noise. Right. So now this one is just going to be very short. I'm sure it's just a short video because it was the same example we're looking. So we finished here the last lecture. The tutorial session, we had one example, two ways of proving it. So we want to prove that this, well, what is this? This is a compound proposition or statement. When we say it's a compound, because compound proposition is composed of simple statements joined or connected with the logical operators. Okay, so here you can see implication, conjunction, implication. Okay, so show that this is a tautology without using truth table. So how do you go about it? Well, one way of doing that is to make use of what we know, implication and disjunction. So P implies Q is equivalent to negation of P or Q. And then we apply the laws of logic that you have seen earlier on, okay? So the first thing we do is to replace this P implies Q by negation of P or Q. So what happens? Well, this is what happens. You end up with P implies Q and P implies Q is equivalent to, so here now you'll have negation of P or Q and P implies Q. Now while you are here, you can do two things. One is you can see this is three statements joined with two different operators, disjunction and conjunction. So you can apply what you call associative law. In case you've forgotten, anyway, I'm allowed to do this to take you back a little bit. Well, associative, not associative, it's distributive. Distributive is where you have different. So you can distribute this one to this, or like this. So you end up with P or Q or R, or like that, okay? So that's the situation we do. So what we'll do is that we go there and we distribute. So we distribute P to minus P and to Q. I mean, to negation of P and to Q. So how do you do that? Well, you just block. If you block this, what do you see? Negation of P will go to P, so you'll have negation of P and P. Then you'll also have negation, you'll have Q and P, and then you connect them with OR. This is what you have exactly here. Let me hide this one. So this is what you have, negation of P and P, or Q and P. Then now, so we said we're doing two things. One is we apply distributive law, and two, we apply this. So this whole thing, while you carry it down here, you also negate it, and then you change this to disjunction Q. So that's what you get from here to there. You apply two things. One, you need distributive law on this, and then two, you negate whatever you have found, or Q, you're applying this property. Okay? While you are here, what's the next sensible thing for you to do? Well, you will now see negation of P and P. This is a statement and it's negation, so these are contradictions. So this is false. Everything else is nothing we can do. So this is what you have. So you have negation of false or the same. Everything remains the same. Okay? Next, what do you do? Well, you know that when you have a statement which is false, and then you join it with a disjunction with another statement, this will be depending on Q and P. Because if this is a true statement, then the whole of it will be true. So false or Q and P is Q and P. So that's what happens. Next stage. Next step, you have negation of, the same thing remains. So here you have Q and P or Q. Then what's the next sensible thing to do? Well, here you'll apply what you call De Morgan's law, which just says that this, you pull out the negation, you have negation of Q. This becomes OR negation of P. And that's exactly what you have in the next stage, right? There it is. And then after that, what do you have? Well, you see, these are three statements that are joined using the same operator. So order doesn't matter the way we take them. So in this case, we group the Q's together. So you have negation of Q or P, which is the next step. And then, you know, the negation of a statement or the statement is a true. You know, it's either it is raining or it's not raining. One of them so makes it true. So that's a tautology there. So this is a tautology or negation of P. And now, when you have true or anything, we really don't care about anything. It remains as true. And hence, we have a tautology. So it's a tautology using that method. Finish, finish. Questions? I don't know. Maybe you already asked. Okay. How else can we prove this? Now, the next way of proving this is to rely on what I was told you in the past. What is that? That now we can rely on the fact that, what do you call this? Let me take you back. Yeah, okay, this one. Conditional statement. This statement is only false when P is true and Q is false. That's the only time this is false. Otherwise, it's true. So we just apply that. So we have, let's go back down here. So the first, let me see. So the first thing, what we are proving is that statement. So this will fail to be a tautology if the conclusion Q is false and the premise is true. So meaning what? That the statement, so what you have said is that this statement will fail to be true, in other words, it will not be a tautology, when there exists a case, at least one case, and we know it's only one case, where for truth values of the proposition variables, whatever P and Q take, it is false. For whatever P and Q, if we end up with a situation where this gives you false, then this will fail to be a tautology. And when is that? Well, we already said, when Q is true and when this is, no, when Q is false and this is true. So basically what I'm telling you that is when the premises are this, and the premises are true, this is true, implies false will give you false. So that's the next step. Just tells you that is when this P implies Q and P is true and Q is false. So in a sense, it's like we are assuming that, is it possible, we are checking, is it possible for that case to appear? Which case? Where P implies Q is false. Is it possible? Well, for that to happen, we must have this. And having this means what? Well, having this we already know. Having this, and this gives you true means that this P implies Q must be true and P must be true, which is the next statement I say there. So for this to be true, both must be true. And then, well, since we already know, now we already know something. If we combine the fact that we know Q is false and we know that P is true, then we can, in a sense, like calculate or work out P implies Q. Of course, we know P implies Q must be true. So the next statement here tells you what? Since Q is false and P is true, then P implies Q using this will be true implies false. And that would be false. So that means P implies Q, according to this, is false, but yet P implies Q is true. So this goes against that what we already have here, which means that it's not possible for this situation to happen. That case doesn't arise. Because if it arises, then we have well, actually, the idea of going against means that now we have a strange thing that doesn't make sense. That's what we may call a contradiction in the future. Hence, it is not possible for this to be true and this to be false. What you assumed from the beginning, what did you assume? That this is true and this is false. So if you assume that, you end up with this contradiction or something strange happening, and therefore that's not possible. And since it's not possible, it means that this statement is always true. It's a tautology. And ladies and gentlemen, that's slide 25 out of 25. So that's it for this week.